So there's a couple of rules that we'll just chat about before we actually try to differentiate a function. So the first one is the product rule. Like the name suggests, it's used for products, so when a function is times by another function. How I like to describe it is I diff one, leave the other, diff the other, leave the one. Okay, and that's how I remember it in my brain. So what I do is essentially, if you want to set it out really nicely, what you can actually do is you can name these u and v and use the like Leibniz type notation. So you have u equals to x squared, v equals to x plus 3, and that way you can say du dx equals to 2x, and then dv dx equals to 1. And then you can kind of just put it, so if I diff one, leave the other, so x squared, and then diff the other, leave the 1, and then put times those together. And then you kind of just make sure everything's simplified, so you get 2x squared plus 6x plus x squared, which is just going to equal to 3x squared plus 6x, and then you just leave it. So diff the other, leave the 1, diff the 1, leave the other, or diff 1, leave the other, diff the other, leave the 1. Essentially, you can also set it up like this and just do like a crisscross match as well. Cool. Right, chain rule, it's used for our composite function, so our f of g of x. So it won't be written as a composite function, it will just say what it is, so g of x equals to blah. But you'll note that two different functions are combined together. So what you need to do is just diff the inside, keep the outside. So diff the inside, diff the inside, diff the outside, keep the inside. So what you do is you leave the inside, pretend that it's inert, and you diff the outside, but then you can't just really do that because that means you're not really considering this a function. So you just diff whatever's on the inside as well. So you just need to care for both parts. So you care part 1, part 2. Cool. And I guess for this one, once again, you can also do like a u and v type situation as well if you want. Okay, so let's go through this one together. So we have cos e to the 2x, and hopefully you're saying that this one will be equivalent to your chain rule because you can kind of see that it's a composite function. So importantly, we kind of need to consider that. So if we look at this, we see that it's y equals to cos e to negative 2x. So we know that this is the inside and this is the outside, right? And I guess another way you can write, so if we have f of g of x, another way to write the derivative of that is f dash g of x and then g dash of x. So what we can do here is e to the power of negative 2x, that's just going to be negative 2 e to the power of negative 2x, and either x I really like because you just basically put whatever's in front of the x out the front. So that's diffing the inside. Now we diff the outside, keeping the inside the same. So cos diffs to negative sine, and that we just keep e to the negative 2x on the inside. Right. So if we kind of simplify and just connect all of those together, we'll just get 2 sine e to the power of negative 2x e to the power of negative 2, e to the power, so 2 sine e to the power of negative 2x. That's all we need. Oopsies, sorry. Negative 2 e to the power of 2x sine e to the power of negative 2x. So it should be negative here. Cool. So yeah, just write it all together and just kind of simplify and clean it up a little.